Water is becoming increasingly scarce. We can alleviate this problem by recycling wastewater. So we need a cheap and efficient tool to control its safety. That's what European researchers are coming up with.
These tomatoes growing in southeast Italy are for research, not food. Here, different methods of irrigation are being compared. Scientists are trying to produce a safe harvest using recycled water.
A factory nearby processes tomatoes, preparing them for storage and distribution to shops. One of the byproducts of these production processes is a lot of dirty water. Usually the wastewater is discarded. What we're trying to do is to find methods to reuse that water for agricultural purposes.
Fresh water is precious in this dry climate, so waste treatment helps overcome the shortages. But testing the water quality is complicated. In most cases, large sample bottles have to be carefully transported to a lab for chemical analysis to see if the water complies with safety standards.
What we really want to know about the water is that it's suitable for reuse, for rewatering the plants, that it doesn't exceed the limits of organic compounds, of nutrients, because there are specific laws that must be applied to what you can irrigate with.
Scientists working on the European Commission's Joint Research Centre have come up with a kit that simplifies the inspection. Instead of sending recycled water to the lab, they pump it through a filter using a specially designed portable box. The chemicals are trapped and preserved for lab analysis.
One of the main advantages is the versatility of this box. It can be used at water treatment factories with surface water or seawater.
So now we have the sample. What's next?
The filters are much easier to deliver to the lab than heavy, fragile glass bottles. Sometimes dozens of litres of sample water are needed to check for various chemicals.
The advantages of using this filter compared to traditional analysis techniques are that the trapping of many organic compounds on a single filter simplifies the analysis, reducing the costs and time and improving sample preservation.
The water sampling device is simple and inexpensive, and the researchers are going to make the design freely available to other specialists in this field. They say their device has already attracted a lot of professional interest.
Our colleagues are generally amazed with the price-performance ratio. There are so many commercial devices offering similar functions, but they're very expensive. So when they see a do-it-yourself instrument that could cost up to 100 times less, it's very surprising, especially when they see that they're just as accurate.